we use for staking or we use for deposit, we can use it for voting. We don't need to touch the free balance. So in this way, you can see how, for example, the locked tokens, the frozen balance, it is overlapping with the reserve balance. So we still have free 20 dot, 19 dot spendable, and we have the untouchable balance is 1 dot. If we go further, and we actually we do more voting, and we vote with the rest. We use the rest of the reserve balance plus 6 dot. So in this case, we basically use 85 in total, 85 dot for voting. We are using all the reserve balance plus we need to actually use some free balance. So you can see that we have some of the free balance now that is also frozen. In this case, the spendable balance is 15 dot. And the untouchable balance, actually you cannot see there because yeah, it's just cut on the bottom. But the untouchable balance is those 5 dot. So the untouchable balance is the frozen in excess of reserve. So it's what we have on top of the reserved. So the reserved is 80 dot. The frozen is 85, which means that the untouchable balance is growing from 1 to 5. And the existential deposit overlays with the frozen balance, but not with the reserved. So we are touching basically the part of where, you know, the 2 free columns there. Again, it's actually a little bit complex. Everything is documented on the Polkadot wiki. If you want to understand how these balances work, again, you don't have to understand how these things work as a normal user. The wallets, they will present the UI, and usually they present the total balance and the balance that is locked. So if you go on Nova Wallet, you actually have this kind of visualization. You don't need to know about free or spendable, untouchable, this kind of stuff. It's only if you're going to touch those functionality in the Polkadot SDK that is actually using these features. Yes. Wait. Microphone. Mic.
Okay, so I'm still not sure I understand the difference between reserved and frozen. Is frozen like changing according to some pre-approved contract or something that specifies how a proxy will control some of the tokens to make it frozen over time?
The frozen balance is essentially the balance that is part of, that is also called locked. Is when you vote or you have vested transfers. If you vote in governance, this is without and with conviction. This is basically a frozen balance. All the rest is reserved. If you stake and any deposit that you pay, this is reserve balance. And reserve balance, the reserve balance doesn't overlays. It's just adding up, right? So is adding up, but the actual frozen balance, it overlays actually.
Okay. So reserved, I can do staking and whatnot, but frozen is specifically for voting, and it can use the reserved balance, but can actually exceed it.
Yes.
In which case, I'll have to allocate more coins or, yeah. Okay, thank you.
Yeah. This is actually an efficient way of not using the free balance. If you are staking and if you have deposits, you can still use this balance for
reusing the staking balance instead of freezing the free one that I can normally.
Yeah.
Okay, thank you.
Yeah.
Thank you. As well as the frozen, you said you can transfer frozen tokens?
Frozen tokens cannot be transferred. It's not it's not transferable balance.
Reserved can.
Yeah.
Okay, so how do you tell if other users have reserved tokens, if you can transfer it over?
Sorry?
How can you tell when other users have reserved tokens in their account?
Reserve tokens, I mean, the UI will display that the available balance is something, and the rest is like in lock, OpenGov, proposal, referenda, and these kind of things. And yeah, I really recommend to try out with Nova Wallet, just with some smaller balance, and it will actually display to you everything. We have another question.
I'll just check the numbers that you're using, like, what was it, 60 for staking, whatever. That's for illustrative purposes. Am I right in thinking 200 is the minimum stake?
Sorry?
So 200 is the minimum stake, is that right?
This is just an example. This is just an example.
Yeah, cool,
You're using
cool,
100 dot, right?
Yeah.
It doesn't take you into account that you need 250 dot to stake. Yeah.
Yeah, Roger here. I forget, if I do conviction voting and some of my tokens are locked because of that, or frozen, are those automatically unlocked afterwards, or do I have to submit a transaction to manually unlock them?
You have to unlock, you have to transmit, you have to basically have a transaction and unlock the tokens. Yeah. And with conviction voting, you have a longer lock. This goes a little bit maybe out of scope, but conviction, basically, if you vote on a referendum and you are on the winning side and you don't have conviction voting, as soon as it finishes, you can unlock. No conviction, right? 0.1 multiplier. If you have conviction voting and you are on the winning side, then you have the lock. And it goes beyond the end of the referendum, right? Yeah.
Yeah. So this is a state of dot explicitly for voting, which I'm guessing the voting mechanisms are built into palettes, which are built into the runtime.
Yes.
And that's when. So would this apply to other tokens other than dot, like these states, or is just this is very specific to dot and dot alone?
Can you repeat the question?
So if we had other tokens, so like I'm not familiar with how
Other tokens?
Yeah, do they fall into these types? Like, do these rules apply to them as well?
Other tokens, I mean, this is specifically now an example using like an example for dot governance.
Yeah.
But if you have other tokens, they live, I mean, on other chains.
Yeah.
And other chains, parachains can implement exactly the same model that Polkadot has or a different model. It depends like how they implement their governance. For example, hydration has the same model, works more or less the same, the governance system with less actually origins, but it's similar.
Okay.
And
so these four states are specific to if you're using governance palette on your runtime on your chain.
These four states is if you're using no, not the governance palette.
Oh.
If you're using the balances.
The balances palette.
Yes.
Okay. Thank you.
And also just to add a tiny bit, this is what is possible to do if you're using the balances palette. You don't have to use all of them. You can instantiate the balances palette on your parachain, and maybe the only thing you're using is just the reserved. Maybe you're having some calls that lock some funds for some time. You don't always have to immediately, gobble up all the functionality. You can ignore the frozen stuff and just take the basic elements you need.
Yeah. Yeah. What? Is there a question there?
It's supposedly answered in the next slide, so I think we're good.
Okay. So I already mentioned this, right? This called storage bloat. I mentioned that if you store something, for example, on Ethereum, the longer it stays, the more actually cheap it gets because there is no kind of like collateral system. Again, like I might be wrong. This is what I know. If you guys have some news from the Ethereum side, I'm happy to hear. What Polkadot has is these deposits that we talked about, right? This reserved balance. And this is actually to incentivize the user to come back to the blockchain and say, hey, you still have this balance there. You can unlock it and use it. So this is a way of like freeing up some space. Dust account and existential deposit. We talked about this. Scaling with data sharding. Yeah, this question.
Because like a question I was preparing, or like I have in my mind that wasn't answered in the previous slides. So my question is about the identity deposits. In the, I think the beginning of the slides, you mentioned it's 1 dot. And my question is, for how long? Are we renting the storage? Are we expecting like it's one-time deposit and it's there forever, or I have to keep the storage by just like kind of?
It is there forever until someone goes and freeze it. It's most of the time is permissionless. Anyone can do it. For example, in case of OpenGov, there are like base deposits for creating proposals, and sometimes you have some good guy that goes there and unlocks, the old deposits. Yeah, the whole idea is to be as efficient as possible, and to do it as a kind of lazy way. You have to go there and do it instead of having the blockchain always to check everything.
Just to make sure I got it correctly, is not the same as Near is doing by having this kind of like a deposit for the storage, and the more transaction you are doing and added your identity, the more kind of like deposits you need or something like this.
Yes, the more activity, usually the more activity you do, you create identity, you create proxies, you vote in OpenGov, you do this, you do that.
So you need to like to
the
add more.
The more like deposits you have like around, yes.
Thank you.
I mean, voting in OpenGov is frozen balance, but you get what I mean. It's related about how active an account is. So here, yeah, basically, I mean, Polkadot is already designed to scale by sharding the data. We talked about that data sharding with Matei. Yeah, Polkadot only needs to store Merkle root. We talked about this, and yeah, we have different decreased storage and storage deposits on parachains, and on Polkadot is 1 dot. We talked about it, and on AssetUp is 100 times less. And an identity, for example, used to be 20 dots on Polkadot, like in the example that I showed. And now identities are on people's chain, which is a system chain. And this is 0.2 dot. It's 100 times less. Again, I really like to basically think about Polkadot as a decentralized computer. And the way is that these system chains, like People's Chain and Asset Hub, Bridge Hub, they're like system processes in a computer. These are like, they are part of Polkadot, kind of like official chains, where we offload all the user-related stuff. All the signed transactions are on system chains. The whole idea is that eventually, the relay chain will be transaction-less, in the sense that the user will not directly interact with the relay chain, but it will interact with the system chains and the parachains. There is no need to go to the relay chain. Why? Because Polkadot must concentrate all the effort on providing security and interoperability. All the rest doesn't make sense. So we can actually use Polkadot sharding on Polkadot's own benefit. Dot inflation. It was mentioned yesterday. Dot is currently having a 120 million fixed schedule inflation. So every year, 120 million are released. And this means that, of course, the issuance increases over time. But because the schedule release is the same, inflation reduces. Now it's around, I think, like 7.5 or 7 something percent. Newly minted tokens are distributed to the treasury, 15%. 15 goes to the treasury, and this is fixed. This has not been like this in the past. It was depending on the staking rate, and it was a little bit complicated and not really, I would say, beneficial for treasury. So now we have a fixed amount of inflation that is going to the treasury, and 85% is going for security. This is a lot of DOT that are going to pay for security, and Dr. Gavin Wood presented at Web3 Summit this year that, hey, we are overpaying for security, we need to do something. So now in the ecosystem, there is like a lot of discussion about what we should do. We should reduce inflation, cap the supply. So there is a whole discussion going on. And I mean, I think the next 2-3 months will be quite interesting. But the whole idea that currently the situation is like this. And if you want to know more, you can go to the fellowship repo and read the newest RFCs. And some great economic explanation. Also, if you're not part of it, please, you can go to the Polkadot forum, you can create an account, or just go there and read. There are nice posts about this topic and around Polkadot overall economy. This is the inflation chart, where we have basically the issuance is a linear. It's 120 million DOT a year, which means the more time passes, the more inflation decreases. Block space. Before diving into block space quickly, is there any questions? Yeah.
I'll give my question. I've had my hand raised for close. I'm here.
Where?
To the right.
Ah.
Yes.
Where? Oh yeah, down there.
Yeah, you got to angle your body differently. I'm to the right. So decentralized storage is an ecosystem in its own right now.
Sorry?
Decentralized storage.
Decentralized?
Storage.
Storage, yeah.
Yeah, it's an ecosystem in its own right. So you have companies like Swarm, you have IPFS and Entify. So what is the distinction between the storage parameters for Polkadot and these other startups or companies or these other infrastructures?
What's the difference between the storage parameter on Polkadot compared to like decentralized storage?
Yeah, like the last couple of slides was on storage.
I mean, decentralized storage is to store large amount of data. You can store a lot of data on a blockchain. Usually you store sensitive information about ownership, data that is not very heavy. So decentralized storage like IPFS, base case of NFTs, right? The NFTs is not stored on the blockchain. The NFT itself is stored on IPFS, but the fingerprint of the NFT and the ownership details and whatever, the NFT always stays on the decentralized storage. And what happens is like the ownership of the NFT changes over time, and this is tracked on the blockchain. Yeah, the whole idea that you don't want to store large data on a blockchain. I mean, people try to do it on Polkadot. They stored like Mamacita Gavin Wood picture during the spam of inscriptions on the relay chain. They pay 250 DOT for one transaction. Someone did it, but there is no actual sensible, smart, use of doing anything like this. Right? Yeah.
So with the treasury distributing funds, there's a burn period, I think,
Yes.
every 14 days or X amount of epochs.
At the end of the spending period, 1%.
Yeah. What was the logic behind 1%? Just so that it's just used and stuff, or is that?
It's just an incentive to spend the money.
Yeah.
It was meant to be like this. I mean, it's an incentive that we have this pot of funds. It's used to boost great things in the ecosystem. We have seen everything in the past 3 years, great things, bad things. But the idea is just, at the end of every spending period,
So the issuance of the 1585 that's generated every year, how much does that 1% epoch take away from that 1585 distribution? Is there does the treasury still grow no matter what because of the 1855
Yes.
split? And then the
Yes. There is a lot of funds going to the treasury. 15% of 120 million dollars is a lot of funds.
so even if they burn 1% every period, they
Yeah.
still raise so much more because of the
Yeah.
issuance.
The biggest problem of the treasury is just managing funds, right? I mean, there's been over a lot of spending initiatives that spend a lot of dots. Definitely, like the burning of the funds is not a problem.
Yeah, it's just an incentive.
Yeah.
Cool. Thanks.
And it's burning, right? I mean, it's actually removing tokens from circulation. You can argue that it's not a bad thing.
Did I hear you right at the beginning of your talk? Is there a particular Rust trait that you said for managing the frozen and the reserve?
There is a fungible trait,
Right, cool.
but I'm not expert about this.
Yeah, I just wanted to write down
This
that.
trait has been implemented, must be implemented on many pallets in order for
Yeah.
whatever all the stuff that they explain in order to work properly. Because some of the funds might also be subjected to slashes, so everything must work. So there are like some complex scenarios
Yeah.
that needs to be taken into account.
Thanks.
Other questions? Cool. Okay, block space. Block space is an umbrella term. It's like something that is very kind of generic. In the specific case of Polkadot, block space on the relay chain is not very, I would say, useless to speak about the space in the block. It's more useless to speak about the computation that is done by the execution course that Matej has been explaining to you. So this is the time that this computation, how much you're using, right? I mean, if you're buying core time, bulk core time, you have that core for that amount of time, you want to make the most of it, right? So because you have an actual computer that is doing this calculation and is spending energy, which are these validators, and this validator must be paid, they must maintain the machines. So you want to use as efficient as possible this computational resource. And actually on the relay chain, you have seen that not much stuff is stored. The information that is stored is just like a small amount of actually the data that are around in the Polkadot ecosystem. So yeah, block space is the capacity of a blockchain to finalize and commit operation. It's presenting blockchain security, computing storage capabilities as an end product. I mean, block space is not measured the same in all the ecosystem. You can maybe talk about block space with Bitcoin. It's actually the space in the blocks. In Ethereum, you have gas, and in Polkadot, you have core time. So the important resource is core time. And core time is the time on a Polkadot core. And the Polkadot core is not physical. Don't know how many of you were able to grasp this. The core itself is virtual, is not real. Is it confusing? Or it's clear? Okay. So you have the validators. The validators are grouped by 5. And these groups of 5 validators, they are actually making some work that is not necessarily committing to the state. So Polkadot actually, it's a very interesting blockchain because the validators are not only committing to state. So you have this dualism that usually, I don't know if you guys heard about or read about Demystifying Gem by Kian, that is also a core developer. Is actually a very nice blog post, Demystifying Gem. You'll probably hear about this towards the end of the PBA. You have this in-core, on-chain dualism. The validators are doing some work in the cores, and they're also doing some work on-chain. So core time is the resource that rollups need to buy with DOT. The DOT gets burned. This is actual revenue for the chain and a deflationary pressure on the token. But most importantly, once you have core time, you can attach to a Polkadot core, and you can send data packages to Polkadot. And Polkadot, what it does, because Polkadot has a copy of the runtime of the chain, can replay everything and make sure that everything is correct. Because, I mean, the parachain can have a set of collators that is centralized. They can have permission system. Maybe they have just 2, 3 collators. You cannot guarantee that, that the chain is actually secure. And this is actually the great use case of Polkadot. You can spin up a chain, and you don't have to like worry about economic security and having like millions backing your machines. You just connect to Polkadot. The Polkadot is providing it to you. But Polkadot is doing this work of like replaying everything that has happened on the edges of the Polkadot ecosystem on these rollups. And if everything is correct, then you're fine, you know. So block space properties, in this case, like you want to call it, again, core time in the case of Polkadot. You want to be available. Core time must be available. Must be easy to get your hands on core time. If you want to experiment with blockchain, you don't want to have a high barrier of entry to limit experimentation, development, and these kind of things. And we've seen, like before, with on-demand core time, people can actually buy core time on the spot like this. And then you want, when you're accessing core time and you access to Polkadot computation, you want this computation to be highly secure. And this is the case of Polkadot. We learn how NPOS work, that the stake is spread homogeneously across all the validators, all the active validators, and the variance between these stakes is as less as possible. Currently 1.4 million DOT. If you go on Polkadot.js the staking tab, you can see all the stakes. There is little variability on the public validators that are available for nominations. So it's actually a very secure system and must be flexible. I mean, what you can do with this core time, you can actually do anything you want. I mean, right now, it's only for rollups. We will see, like, in the course of this PBA towards the end, like the next iteration of Polkadot is to actually make it general. The computation offered by these cores can be used by any application, any task, not only rollups, not only blockchains. So this is the next iteration of the development. These are very important properties of block space, also discussed by Robert Habermeyer, one of the co-founder of Polkadot, in many talks. Yeah. DOT as a utility token. The DOT token serves multiple purposes in the ecosystem. We have talked is one great utility, probably, I mean, I would say the most important one is purchasing core time. Then you have another important feature that is staking, which is contributing to security, voting in governance, paying for fees, deposit. We have talked about this. And the first utility, so is purchasing core time. And I really like to describe Polkadot as a decentralized computer that provides secure and verifiable computation. So if I'm doing stuff on my computer and I'm telling you that I'm doing something, you can actually verify that is true. It's my computer. I can do anything I want. But if you do something on Polkadot, you can actually verify anything that has been done. So Polkadot is a decentralized computer that happens to be also powered by blockchain, but not only, there is not only a blockchain component, right? So Polkadot schedule roll-up data processing on a virtual multi-core CPU. We have virtual cores, which means that we have a virtual CPU like a computer, a normal computer. And roll-up chains can access Polkadot computation via virtual cores by purchasing core time with the DOT token. Is it any question? Is there any question? Yeah.
Just like the previous, I think, slides, one or two, you mentioned that the feature of the block space is like to give you the flexibility. And here, when we say flexibility, like for the parachains to store whatever transaction they have in their own like things, or it is like the validator can add whatever data in the block itself, similar to what the miner can add in the logs in the block in Bitcoin, for example. Again, when it's come to flexibility, the validator can add in the block logs, whatever, any data, or the flexibility you are talking about, like the parachain can add the transaction, whatever the transaction has data, and this is where the flexibility you're talking about.
Flexibility is more what you can do with core time.
As a parachain or as a validator?
As now as a parachain, but in the future as any task. What use has core time, right? I mean, currently core time is only used by parachains.
Okay.
But eventually, this is a resource that can be used for anything that you want to do, right? You want to deploy maybe a contract, you want to define your own kind of use case, permissionless, in a permissionless way, you maybe can do it. But this is not something that is at this stage right now, right? I mean, but then there are different way of also looking at it, right? For example, on Ethereum, you can say that the block space. I mean, what you can do on Ethereum, you can yes, you can store, for example, a smart contract, right? This is actually a very flexible thing, also a generalized version of Bitcoin, you can say, right? So there are different nuances about this, but so evolution of blockchain marketplace. Core time allows agile scheduling of Polkadot computation under the assumption that cores are a resource available to anyone. So before core time, cores were assigned one-to-one to a rollup. This is kind of a very fixed way of doing things, and also kind of gatekeeping in a way that you cannot really be highly flexible. And you have to think that these cores were leased for a very long period of time. And if the chain is not using anymore, it doesn't have many users, you can say that this computation on that core is essentially wasted. You are paying those validators for security, but that chain maybe doesn't have a lot of traction, doesn't have a lot of users. So the idea here is that this evolution with core time is to make the possibility to have Polkadot that is becoming more and more like a traditional computer. Like the scheduling of tasks that happen on the Polkadot virtual CPU are becoming more and more similar to the scheduling of tasks on a traditional computer. We have seen that core time can be split or interlaced. By the way, these figures here, you have core 1 to core n, and in each core, you can see that you can think this as a parachain block, and they're all of the same color, right? On core 1, they're all the same color. It's the same parachain all the time. And on core 2, core 3, core n, this is different chains on different cores. That's it. But with core time, what we can actually do is we can actually have different chains on the same core that are scheduled concurrently. So we can have the core that is doing concurrent computation. So it's you go on that core, and then I go on that core, and then you go. We can split the cost. This is to optimize the use of this computation that is done on the core. This 2 seconds execution that we have, this is very valuable computation. This is backed by billions in security. This is verifiable, highly secure computation. You don't want to waste it. So this is very interesting shift of Polkadot being more democratic. You don't have the auctions that there were at the beginning that were kind of like gatekeeping. I mean, the first auction were 34 million dots for a core for 2 years. Moonbeam, A-Star, 30 million dot at a price of $40 dot in 2021. You can imagine how much those core were valued. Of course, it's a lot of hype. There's a lot of stuff. It was 2020, 2021. But, you know, it's the more time passes, the more like you want to really think about the product that you're building. You want to make it accessible, and you want to make people experiment with it to build toolings for developers. Otherwise, no one builds anything, right? This is a very important step. Another thing is, so this is basically core 1 there and also core 2. We can see that this is basically the interlacing feature. You can buy a core in core time in bulk for 28 days. You can decide to split it with another chain. You lose the right of renewal. This is very important. The renewal price is, you know, you lose the right of the renewal price that also Matej was basically showing to you.
When the next RFC 17 actually goes into implementation, you will no longer use the renewal rights when you interlace.
Okay.
So soon, no longer a limitation.
So you won't lose the renewal rights if you interlace?
Yeah, you can trade it around and it will still be working fine.
Okay. So some changes are happening. A rollup can schedule on multiple core leveraging parallel computation. So we don't have only concurrent computation, we can do parallel computation on different cores. We can have one rollup that can be, because maybe that core it's already, you know, used, that computation is not enough. We can actually schedule on one more core, and this is the case of like core 3. And with core N, you can see that we have the same color actually on, you know, the same color of the blocks within the same slot. This means that basically that chain is sending 2 parachain blocks on 2 different cores instead of targeting only one. And yeah, core time sale use periodic Dutch auction. This, we have seen it before. Dot utility staking. So are there questions about core time? About buying core time with Dot? Okay. Dot utility staking. So given the existence of a value-bearing token, it can be used to provide security to the network. This is a proof-of-stake network. And you guys, anyone that has DOT can actually participate to staking. So you can stake with as a solo staker, but you can also stake in a nomination pool. And the nomination pool is basically behaving as a solo staker, as an account. But because, so why nomination pool were introduced is because only 22,500 nominators are earning rewards. We have someone speaking on the mic.
So is
outside,
there
I
any other
think.
tech stack that is like virtualizing some coding, those codes, or like it's like totally based on like if you're buying the code,
There is some,
it will be like market event virtualization.
It is market driven.
Okay, yeah. As there is no physical.
I think we heard everything, eh? We heard everything. All your DOT wallets, all your balances and private keys. Okay. No, it's so as a DOT holder, you can actually participate democratically in staking, right? So you can stake, and the problem is that only 22,500 nominators are actually getting rewarded because of this backlist system. Again, if you don't, I don't want to go deeper into the backs list, but there is actually a page on the Polkadot wiki about it. But because there is a limited number of people that can actually be rewarded, there is also an amount of DOT that is variable every era that you need to have in order to receive rewards as a solo staker. And it's quite high. It's 500 DOT, 400, 500 DOT. It's on the staking dashboard. I don't know now exactly the number, but not all people can have 300 DOT to stake. So they can go to a nomination pool. And the nomination pool pulls the funds together of different people. The minimum amount of is 1 DOT. And this ensures that basically these people can get also the rewards, although they have a balance that is below this minimum active bond is called. This is clear.
I have a question regarding staking.
Yeah.
So in the previous slide, you showed something about an RFC regarding flexible inflation rate.
About?
Flexible inflation rate.
Flexible inflation rate.
Or something of that sort, right? Like something that that you can control the inflation.
I'm not sure.
Is
where? Here?
Wait,
The chart?
Yeah, there's that PR regarding the inflation formula.
Inflation. There is no inflation formula here.
Let me just.
Oh, wait. Here.
Yeah, that one. Is the staking reward rate related to this in any way?
The staking reward rate.
Or
like how much staking rewards you get.
Yeah.
The staking rewards rate is dependent on how many people are staking on the network. Yeah, how many funds are staked on the network.
But I would naively assume that the inflation rate would be dependent on that.
The
right?
inflation rate. I mean, there are. The release schedule is fixed. It's 120 million DOT.
Okay.
Which means the inflation rate of the DOT token decreases over time, right? Because you have you have the same release schedule, but the circulating supply actually increases, right? So the more time passes, the more the inflation is less and less over time, right? Like the chart here. So in 25 years, what is it? 25 years, the inflation of pork, if it continues like this, which I really guess it won't, but the idea is that it will drop from 7% to, I don't know, 2.5, right? So in 25 years is 2.5, the inflation, 2.5 annual inflation. If 120 million DOT, and without accounting of deflationary pressure from like core time sales, treasury burns. You know, it's the more Polkadot gets used, the more core times gets valuable because it's a scarce resource. And if you believe that secure computation is a valuable thing, which is, you can think that in the future core time will be valuable, which means that more funds will be burned, which means there will be an additional pressure on the deflationary pressure on the token itself, because you will remove token from circulation because this token will be burned.
Yeah, I guess my question is basically regarding that, because like if you think about it as different pressures, and then you have these levers to control like how much is there in circulation, right?
Yeah, I mean, this is a very simplistic thing. This is just taking into account of the release schedule, and that's it. I mean, we don't know the utility, how, yeah.
Yeah, okay, thank you.
Yeah. So we were here. Governance. Oh, we have another question?
Yeah, no, small question. So every time the DOT price goes up, the agile core time also goes up. Like
Yes.
it's more expensive to buy computation
Yes.
in that sense. Even and how is the price going up in dot? It's like supply and demand. Like every time they buy more dots and put more money into the ecosystem.
Man, I mean, I don't have a crystal ball, right? It's like no, it's markets, it's supply and demand. It's
Yeah. Even if they are not using any computational resource, like if the price goes up, it's just a shared core time.
Man, meme
goes up.
coins are an example,
Yeah.
right? Meme coins, they don't have a really great utility, but you have meme coins with 1 billion market. It's also speculation, right? It's many things together.
Yeah.
So it's adoption, it's speculation, it's politics, it's like a lot of stuff.
Yeah.
I mean, we're not talking about the dot price here, right? We're talking about, of course, the dot goes up, the price you expect of this core time will be more valuable, but also could remain the same, right? I mean,
I was wondering if it will affect like the core time that you buy as a service. And
I mean, you
like
could
this-
argue that if core time is the major revenue stream of the Polkadot ecosystem, because I mean the funds are directly burned, right? Which is essentially pure revenue. This fixed supply for the DOT token is set to 2.1 billion. You essentially reduce a lot of tokens from circulation. So you expect like every token holder will have a bigger share of the circulating supply, right? So it's yeah.
Okay.
But you get what I mean, right? It's all about utility. It's all about how this resource is used and how easy it is to access, how easy it is to use, how you guys can interact with it and build great projects.
Yeah. I just wonder if the dot price goes up in the market, then people will remove that money on the agile core time because of the price is too high for transaction. Maybe I don't know. Just wondering if that could happen.
Okay. We can maybe discuss this tonight at the party.
Hi, Juan here. After the question from Emi, it triggered something in my mind, and it's if the usage of the dot or the Polkadot computer is cheaper if the token price gets down, and more expensive if the token price gets up. It's in game theory, it's a bit weird because the investors and the holders of DOT are interested on the price going down, because that way it's cheaper for them to continue using the machine. And in the opposite, the ones who are not using the machine are the ones who want the price to go up and are the ones interested in.
No, but I immediately stop you here because the price can go up, but the amount of dots that you need to buy core time can go down, and the actual price in USD can remain the same. You don't know how it can go. It's just
Yeah,
these are purely market related and actually speculative.
Yeah, but I'm not talking about actually knowing the price, because that's impossible. I'm talking about incentives. So if the users, it's a bit weird, don't you think? If the users of the system are interested in the price going down, they might even act like a cartel and collaborate to dump the price. And the opposite, the ones who are interested maybe in the users of the Polkadot failing, can also organize to try to pump the price.
Yeah, man, bears and bulls. I mean, buys, sells. This is market.
Okay, so Polkadot, well, Parity in general doesn't care about how does the price moves.
No, the idea here is to make a system as agile as possible to do the market figure out what's going to happen. So if the system is agile as in general as possible, if anyone can access core time, if the way it's scheduled is efficient, and it's democratic and blah, blah, all these things, right? And it's easy because you can buy core time on, I don't know, an exchange or, on a platform, because actually this is commoditizing time, right, on a machine. So you can actually, there is a market right now. So, people are speculating on it, and that the market will figure out eventually how it will go. But it's all about, in the end, it's all about usage. But you can also speculate, right? There is the core time baron that basically bought all the cores. The cores were not available. It was a huge mess, spiked the price. The fellowship had to intervene and actually allocate two cores because two parachain forgot to renew the core. All these things. Like in the end, it's also like you can speculate on core time. Core time is there to be bought. You can actually go there tonight and buy all the cores. I mean, not all the cores, but most of the cores.
So, question.
And just to be clear, there's a bit of a misconception. DOT price going up doesn't make core time more expensive. In the end, it's still an auction. You will pay as much DOT as you want to pay for it. If DOT went, 2x in the price, you can just compete on the market and pay 2 times less.
Yeah.
It's not a fixed amount you are paying. It's an auction. If it would be, okay, you are always paying 10 DOT for core time, yeah, I would be worried about it. This is just not how it works. This is why we have all those auctions. We have those dynamic methods of discovering the actual price of core time so that it is kind of detached from the value of DOT.
Yeah, you kind of like covered what I was going to say, which is it is an auction and it does expire. So like even if the price is volatile, if you sell it now, like when DOT was $1 and you bought core time, you can resell it before the auction expires. And that's an arbitrage opportunity for someone if they bought it. But the time, they can't hold it in perpetuity, like how they hold DOT in perpetuity. The core time will expire, like if the option for that core time does expire, doesn't it? Because you purchase core time within a certain period.
I mean, if you buy core time, you want to use it, because after some time,
Yeah,
this will
but
be
there would
worthless.
be people who would try to speculate on like, oh, I bought the core time to resell it because I bought a bulk of it.
Yeah.
But they can only do that for a certain period of time because the core time does expire. And the auction happens again. And if the price of DOT is up at that point, then the price of the core time would change according to the price of DOT if you're looking for a stable peg to go for it. So the argument, like, I can see what he's saying, or trying to pump the price of DOT, but it won't work because of the auction mechanism and the way that core time does expire, unless I'm misunderstanding it. No.
Yeah, let's move away from the pump and dumps. No, I get it. Yeah, it's in the end, the market will figure out, how core time will be priced, and we will likely be, there is a use aspect of it, what I can do, and there are the developers that think, the chains need to buy it, but it also be a lot of speculation on it. There will be people buying because they think that oh, now is a good time to buy core time because those chains, I don't know, they need it, or these things, right? So yeah. Huh? Yeah. Cool. So DOT utility governance. We have seen staking. We have seen core time. Governance is another utility of DOT. You can vote on different proposal. You can also create your own proposal. There is no entry barrier. I mean, the entry barrier is essentially that you need to place a decision deposit. There will be like a governance lecture during this PBA. I will not go into detail right now, but essentially, the Polkadot has its on-chain governance system called OpenGov that is used to, for example, access treasury funds, upgrade the network, support the technical fellowship, because the technical fellowship is paid. They have salaries, and these salaries are paid directly from the Polkadot treasury, and support parachain teams, support events, educational initiative, PBA, other events. So it's a lot of value that gets added into the ecosystem. The idea of the treasury is it's a decentralized pot of fund. The OpenGov decides, and you can actually fund anything you want, anything, like Conor Daly, Indy 500, Inter Miami. They are big sponsorship. You can argue about the utility of the sponsorship, but this has been voted by the OpenGov, and they actually they actually went to fruition. OpenGov structure, there are, very shortly, there are different origins. Compared to Ethereum that has account abstraction, Polkadot goes a level deeper and has origin abstraction, where you have many, many origins. For example, one origin is the sign origin or like something similar that is basically dedicated for user-related transaction for actually personas. But you can have like origins like in OpenGov, like the root origin, big spender, treasurer. All these origins are there to, for example, in the case of the treasury, you can access treasury funds. You can also, and you have the technical fellowship. The technical fellowship doesn't have any power on the governance or on the treasury or anything else like that. It's there. The only power that they have, they can whitelist proposals. By proposal whitelisting, it means that the proposal has a different lifetime. It gets proposed. There is a leading period. There is a voting period. There is a confirmation period. And then there is the enactment period if the proposal passes. Of course, if something is very urgent and there is a bug and is something that needs to be enacted as soon as possible, the fellowship can step in and whitelist that proposal, which basically shortens the life of that proposal, right? Like it will get through very quicker than without the white. It's basically a fast track. This is essentially the only really influence that the fellowship can have. Of course, the fellowship has technical knowledge and does a lot of things. But when it comes to the actual code and chain features, the fellowship can do this. OpenGov origin and tracks, I said like leading, decision, confirmation period, and enactment. Like you need, the leading period is the minimum time capacity. You need a decision deposit to place that is track dependent. This is to avoid that we have spamming. And of course, depending on how many DOT you want to tap into the treasury, the decision deposit might definitely higher for big proposals. And then the decision period is where people are voting, and you have this different like support, these two different curves. You have the approval and support curves that needs to be met in order to a proposal to pass. And then you have the confirmation period that you need to meet this support and approval for a specific amount of time in order to actually pass. And then you have the enactment period. And here we have some example for different origin. We have the root origin. You can see the decision deposit for the root origin is 100,000 DOT. Whitelisted caller proposals, staking, treasurer, and other example of origin. And you can see for each origin, the track is different. For example, for the root origin, the prepare period is, the leading period is 2 hours. For the whitelisted caller, you can see that this shrinks to 30 minutes. We'll skip this because there is an OpenGov class. And yeah, conviction voting. You can vote with conviction, meaning that if you want to have more voting power, you can have up to 6 times more of your actual balance to vote. If you have 10 DOT, you can actually vote with 60 DOT, 60 voting power, but you're actually locking those dots for 224 days. So the more, sorry, there's a question?
I mean, after this time, they will have this voting power, correct? Or once I locked my assets for this long time, I will multiply my voting power by 6.
Yes. But then if the referendum passes and you are on the winning side of the referendum, you have a lock of 224 days. If the referendum passes, you are on the losing side of the referendum, you can unlock. You will see.
There is no attack in this case? Like
Sorry?
there is no attack?
There is no?
Attack, like
Oh,
I
yeah.
can, because if I know like this is gonna be, it's a problem with DAOs and voting in general, when I know like the majority, because like it's on chain, correct me if I'm wrong, I know like the majority is voting for this proposal and it's gonna win. So I'm maximizing my voting power by sex immediately, and then I'm voting and I'm maximizing my profit later on. I'm getting correct, or I'm missing something?
There is no
I'm not
profit
sure
in
I'm
voting.
getting.
I think she's saying, instead of like, so you vote, you do conviction voting, you lock for 224 days, you're on the winning side. Are you saying when you're on the winning side, that 224 days must expire before you can use it again to conviction vote? Or is it that if you lose,
You can reuse locks.
you can't reuse lock?
You can reuse locks. Yes,
Okay.
locks are can overlay.
Okay.
So if you are voting and you have a lock, then you can vote on another referendum and use the same lock. But depending on how much conviction you use on the first or the second, you might, if you're using like 0.1 conviction on the first, and on the second you use like 6 conviction, then you will end up with, the longest locks decides in the end.
And if I lose, the lock is unlocked. Like I don't have it locked in again.
Sorry?
If I'm on the losing side after I've done a conviction voting, I get back, it's unlocked and I get back my.
Yes. So if you are, now here is a little bit small. Where is it?
My point here is, let's assume I'm watching on chain the transaction, and there is a proposal which is likely to win, and I have some dots. I made the stake and make it kind of like to maximize, or like to multiply it by 6 to increase the voting power I have.
Yeah.
And then I participated in this voting.
Yes.
I voted for the winning side, which is likely to win.
Yes.
Is this kind of attack? Because like
Why? What attack? Well, there is no attack there. What attack will you?
Because in this case I'm trying like to maximize my, because what will happen when this proposal wins?
First, if the proposal is likely to win, why would you vote? Right, in the first place.
Okay.
I mean, it's like, like there isn't. I don't understand yet. Let's bring this like maybe after the lecture, right? Because the thing here is like, if you are a solo voter and you vote with no conviction, the reference is ongoing, you can remove the vote and unlock straight away. If the referendum ended and you are on the losing side, you can remove the vote straight away, but also if you're on the winning side, you have no conviction, right? You absolutely no conviction, 0.1 multiplier. If instead you have conviction and the referendum is as handed and you are on the winning side, you have the conviction lock. But if you are on the losing side, you can remove the lock, right? The lock is applied only if you are on the winning side. We'll get this maybe in... So the part of ecosystem, this is the second part of the lecture. I will like go very quick because it's mostly like tools and stuff. If you don't know, like there is this gem prize, 10 million DOT for developing clients for the gem protocol, the gem upgrade, the next upgrade of Polkadot. This is a lot of people are working on this. We have a lot of implementers. Go into the, there is a website, right? Which is the website?
Greypaper.com.
Yeah, greypaper.com. So you can actually see everything. You can read the gray paper. So system chains, we talked about those. Current and future system parachains. The current we have actually Asset Hub, Bridge Hub, Core Time Chain, Collectis, People Chain. Then we have staking. Staking is moving to the hub, and governance.
To the hub as well.
To the hub as well. Okay. So eventually, everything that is on the relay chain will move up to system chains. Polkadot rollups. If it's a great tool to explore rollups, you can go to Subscan, XCM. there is a nice representation of the current rollups on the Polkadot ecosystem. We have many of them. We are touching different verticals, probably the most important ones. We have smart contract chains, Moonbeam, A-Star, Polkadot Hub, very soon. Decentralized finance, DeFi, hydration app chain. This is definitely something I will look into. It's very interesting. They're doing very innovative things. They have an omnipool and quite a lot of success lately with 400 million TVL. Liquid staking and derivatives, also here, a lot of success for Bifrost with the voucher dot. There is also an ongoing collaboration with Hydration. Decentralized social frequency, MiWi, the MiWi platform. Decentralized identity, DID, Kilt, tokenization, real world asset with Excavate. Gaming with Mythical. We also have like some kind of meme project that have adventured into gaming, Gavin Wood, Thinknomics. NFTs, we have platforms. Of course, the NFT standard is on Asset Hub, but we also have a unique chain that also they have their own like very advanced NFTs, fractionalized NFT, nested NFTs. This is actually a project going on with Gavin Wood, which is Wood Universe, that you will be able to really create your own wood cabin, and this will be made with nested NFTs and stuff like that. Really cool stuff. We have an NFT marketplace that is quite popular in the ecosystem, which is Codadot. Bridges, trustless bridges, no bridge, hyperbridge. Snow bridge with Ethereum, and hyperbridge is with different chains, and it's a ZK-based bridge. And file storage with Crust. So these are all, they're not all, but these projects are, except a few, like Codadot is just a platform, but most of them, they are rollups. These are like layer ones. I don't know, like here is a little bit ambiguous, layer one, layer two, but these are like rollup on the Polkadot ecosystem. Established rollups in the Polkadot. This is an example of hydration. You can swap, trade OTC, ELDCA. You have bonds, lending and borrowing, strategies with Gigadot, GigaETH. These are like yield-bearing assets that if you hold those assets, they will appreciate over time because they are yielding they're bearing the yield of like underlying V dot, A dot, and all these like derivatives. Then you have cross-chain staking, referrals, a lot of stuff going on. Bifrost, mostly V staking. MiWi, this is a decentralized social network. It's an interesting project that is like powered by frequency. Mythical Games that recently released the FIFA rival game, and they are releasing now the Pudgy Party with like huge collaboration with Pudgy Penguins. We have gaming with some like memes or cult community coins like Flappy Wood and the Wood Universe that I talked about with Unique. We will probably launch very soon. It was quite interesting to explore. Yeah. Then we have wallets. I would say we have wallets and extension. The most used and what personally I don't want to give recommendation, but it's at the most widely used in the ecosystem, mobile wallet, Nova wallet, and sub wallet. Nova wallet, we can do pretty much everything. You also have proxy, multi-sig, and governance support. And then for browser extension, you have Talisman and sub wallet. Generic ledger support has been mentioned briefly. The new generic app is, you can use it on any chain, as long as they implemented the right structure in the metadata structure. They actually, you can use the same ledger app on all the parachains, on most of the parachains. And actually, if you want to be sure that the chain supports the ledger, you need to go to data.parity.io, and there is a metadata section, and it's listing all the chains that are currently supported by the Ledger generic app. So please, before doing anything with Ledger on chains and being stuck until they implement it, just check. Block Explorer, we have seen the Polkadot.js UI, very famous, developer-oriented, definitely. We have Subscan, we have other. I would say like Subscan is one of the main used. Governance dashboard. We have bulk assembly and Subsquare. It's up to you which one you want to use, depending on, I don't know, like philosophy, how they treat, how they store data and these kind of things, or just UI related choice. Polkadot.forum, very interesting to just stay up to date. You can also start a discussion or engage with current hot topics like inflation and cap supply. If you are an expert in a finance background and stuff like this, you can definitely engage. And in general, like there is for any background, any topic, right, in here. DAOs, of course, if you go to OpenGov, you will face a lot of drama and a lot of politics. You have the Polkadot Technical Fellowship, is one of the DAO. Then you have the Polkadot Alliance, Polkadot Ambassadors. These are on-chain. These are on-chain DAOs. I mean, Ambassador is still like, you know. Then we have actual off-chain DAOs that you will face in OpenGov voting, PBA alumni voting DAO, which is will be you. Then Chaos DAO, Kusamarian DAO, Hungarian, and then so on, like many DAOs in the ecosystem. And yeah, I mean, about the fellowship, a lot has been said already. There is a GitHub repo that is dedicated, and you have all the requests for comment. So there is a manifesto. There is also a website. And yeah, anything you need is on the Polkadot wiki. All the links are there. Just type. There is also an AI chatbot. You don't need to scroll through the pages. Just use the chatbot. And yeah, RFCs, and that's it.